Says in the diagram, ACDF is similar to VWYZ. And a reminder that a similarity statement works the exact same way as a congruent statement. We know that by looking at this similarity statement that angle A would be congruent to angle B. We know that angle C would be congruent to angle W, and so on and so forth. D, 1, 2, 3, would be congruent to Y, and then Z and F. Something else it tells us is which side lengths are in ratio. Which side lengths are proportional. And here's how you'd work this problem. It says find the value of x here. And we're going to go ahead. The next problem is going to tell us to find y. So we'll go ahead and find both of them. The way that you find it is, there's two different ways to do it. Number one way of doing it, you can find a scale factor. And let's do it. Let's look at that way first. Let's find two sides that correspond, two numerical sides that correspond. I know that YW, which is between my 2 tick marks and 3 tick marks, is in relation with 9. So if we want to, we could take that 6 and we could take that 9, and we could ask ourselves, how much bigger is one than the other, and we can find the scale factor. What is the scale factor there? 6, here's how you find it. 6 times my scale factor will equal 9. I want to know how many times bigger is 9 than 6. It's a simple one-step equation. If you want the fraction form, guys, you don't even need a calculator. To solve this, let's divide by 6. Mark it out. S is equal to 9 divided by 6. Reduce that. Divide by 3, divide by 3. 3 halves. That's the scale factor from, again, since that's bigger than 1, if you actually divide that, that's 1.5. Since that's bigger than 1, that's the scale factor from the small shape to the large shape. You'd multiply times 3 halves. If you wanted the scale factor in the other direction, you'd multiply times from yesterday, 2/3. The small shape is 2/3 as big as the large shape. The large shape is 3 halves as times as big as the small shape. So now, look, if we want to find x, help me out, Rachel. FD, that's the length x there. What does FD correspond? It's not equal in length. What is, go ahead, YZ. FD corresponds with YZ, so how can I go from 10 to the length of x? Yeah, multiply by 3 halves. What did you say it was? Oh, I thought you were saying. Does everybody know how to multiply fractions? I know you do. You can multiply 10 by 3 halves. The easy way, multiply top and bottoms. That'd be 30 halves or 15. The other way of doing it. If you don't want to use scale factors, here's your other method. This is probably the method that you've used all these years up to this point. Find the corresponding sides. And again, if you need to, map it out. 10 corresponds with x. 6 corresponds with 9. 3y minus 1 corresponds with 12. And we don't know anything about it, but AC corresponds with WB. Write a proportion. A proportion is two ratios that we know are equal. If these two shapes are similar, we know they are in proportion. What that means is the ratio of 6 to 9. One side length of the bottom one in relation with the side that it corresponds with is going to equal another side length in the second one in relation to whatever it corresponds with. 6 goes with 9, 10 goes with x. Everybody see that? And we know that those two things would be equal because they are similar, they are proportional. Again, 6 goes with 9, 10 goes with x. And you could go a step further and say 3y minus 1 goes with 12. Reminder of how to solve proportions. I don't know, we've reviewed this year. We've done proportions this year? I can't remember. Proportion is two fractions that are equal to each other. Here's how you solve proportions. This is the long way. I want to actually show you why you're doing what you're doing. A proportion is an equation. This is going to get us ready for next chapter too. A proportion is an equation. I want to get rid of divide by 9. How do I move it over there? Good. Mark it out. I want to get rid of divided by x. How do I move over here? Good. That makes sense. You have eliminated all fractions from your equation. You now have 6x equals 90. Chris, next step, how do I move the 6 over here now? Since it's multiplied, you divide it. Good. And x is 15. That's the same answer we got over here. Now that we've done it the long way, 6 over 9 equals 10 over x. Does everybody remember the shortcut? Find the two numbers that are diagonal with each other. What do you do with those two numbers? Shortcut for solving your proportion. Take 9 and 10 and do what with it? Multiply them, thank you. Multiply these two together, you get 90, and then what do you do with the 6? Divide. Good. So you're going to do 90 divided by 6. Multiply the numbers that are diagonal and divide by the other number. 90 divided by 6 gives you 15. Same answer. Okay, that's your shortcut. Since obviously we really don't remember how to do that, let's do it again, or another one. If it was x divided by 3 equals 4 over 12. Shortcut to figure out what x is, find the two numbers diagonal, multiply those, 3 times 4 is 12, divide by the other number. Answer that would be 1. One more. 5 over 7 equals x over 10. Find the two numbers that are diagonal, 5 and 10, multiply them together, divide by the other number. 7 with 1 left over. Which is about 7.14 if you actually divide it out. Okay. That's solving proportions. Okay, the next problem is going to ask us to find y. There we go. Let's go back and find it here. Again, map it out if you need to. 10 went with x, which by the way, x is now 15. 6 went with 9, and 3y minus 1 goes with 12. 3y minus 1 goes with 12. Now be cautious, be careful with this. When you're setting these proportions up, use common sense. You're not going to say 3y minus 1 goes with 12 and 10 goes with x. You got two variables. Don't do that. Now that you know what x is, you could take that out and put a 15 in. Yeah, you can solve it. But when you're setting these proportions up, set them up in such a way to where you don't have to fool. You don't have to fool with two different variables. 3y minus 1 goes with 12. 6 goes with 9. That way you have only one variable. Little bit more difficult proportion. You don't have just plain y equals something. Okay? You have 3y minus 1 over, you have to solve this in slightly different. Here's how you do it. What I showed you a while ago. To get rid of divided by 9, mark it out and multiply by 9. Look at what I just wrote. The way I've written this, what's 9 being multiplied by? Anybody? Here, the way I wrote it is being multiplied by 3y. You don't want it to be multiplied times part of it. That 9, as you move it across to the other side, needs to be multiplied by the whole thing. Put you some parentheses around that. To get rid of 12, divided by 12 turns into times 12. So here we go. Distribute 9. You now have 27y minus 9 equals 6 times 12, which is 72. That's easy. That's a linear equation. That's what we've been solving. To move minus 9, we do plus 9. You now have 27y equals 81. If you need to use your calculator, divide by 27, you get y equals 3. Let's check ourselves. I want you to be comfortable doing what I'm about to show you. Y is 3, that gives me 3 times 3 is 9, minus 1 is 8. So again, in order to check this, these two trapezoids are supposed to be similar. If they are truly similar, the scale factor should hold for all sides. So we found the scale factor a while ago. I think it was like 1.5 or 3/2 going in this direction. We'll call it 1.5. And it was 2/3 or 0.6 repeating going in the other direction. So the way you can check that, take 8, multiply it by that 1.5, and you should get 12. And you do. Take 6, multiply by that 1.5, you should get 9. Take 10, multiply by 1.5, you should get 15. Or you can do it in the other direction. Take 12, multiply by 0.6 repeating. How do you do that? You enter your calculator, you do. 12 times point, and you get 7.99999. Use common sense. I did not multiply by 0.6 repeating. I multiplied by point, lots of sixes. That's not 0.6 repeating. So my answer is not going to be exact, but it's going to be pretty close. When I multiplied 12 by 0.6 repeating, I got pretty much 8, right? So you can do that for all the sides. 9 times 0.6 repeating should give you 6. But again, that shows you what scale factors do. They should hold for all sides. Moving on. Find the value of each variable if these are similar, and they've even marked it for us. This angle is congruent to this angle. This angle is congruent to this angle, and obviously by the third angle theorem, L and S will also be congruent. Set up a proportion. You can use scale factor. Well, actually, scale factors might be easier here. From the small triangle to the large triangle. Somebody look at this. What's your scale factor? How much bigger is it? 2. And be cautious with something. 2 times bigger, not plus 2 bigger. 2 times bigger. Scale factors must be multiplication. Here's something else I didn't think about. Another spot that you see scale factors. Ratios are scale factors. Model cars, 1 to 32 ratio, that's a scale factor of times 32. Okay, model cars are similar to the original, so that's somewhere else that you do see scale factors. But anyway, back to this. The big triangle is twice as big as the small triangle. 2 corresponds with 4. 6x minus 3 corresponds with 3, right? How do I know that? Because it's the side next to the 2 tick marks. And 5 would correspond with 3y minus 2. If you need to map it out like I just did, go for it. The big triangle is twice as big as the small triangle. So one way of working these problems, 6x minus 3. Question. It corresponds with 3, but doesn't equal 3. Will 6x minus 3 equal 3? No. No, guys. It's not. These two shapes are not the same size. But we do know the relationship between the sizes. What was 6x minus 3 equal? And it's twice as big. 1 equals 6. That makes sense. That's how you could use scale factors to solve this. Add 3, divide by 6, you're going to get x is 1.5. 3y minus 2. What's it going to equal? Okay. Add 2, divide by 3. That's how you work it using scale factors. The side lengths of the second triangle, I already know what they're going to be. This is 3, 5, and 2. Well, this one's twice as big. How do we know that? Because of 2 and 4. So since this is twice as big, the side lengths of this triangle will be 6, 10, and 4. Because your scale factor is 2, it's double. Here's your other way of working. If you don't like that way, use proportions. I know again, let me map it out. 2 goes with 4. 5 goes with 3y minus 2. 3 goes with 6x minus 3. 6x minus 3 corresponds with 3. They're proportional. If 6x minus 3 goes with 3, I also know that 4 goes with 2. Solve the proportion, find out what x is, you're done. You work it the way you want to work it. The only problem with scale factors is sometimes they're not nice and neat like times 2, times 3. Sometimes it might be times 5/3 and stuff like that. So this way is probably your best way all around. Solve this to get rid of divided by 2. We're going to come over here and we're going to multiply this by 2. Gives me 12x minus 6. To get rid of divided by 3, we're going to come over here and multiply by 3. Gives me 12. Add 6, divide by 12. You get the exact same answer for x. To solve for y, 3y minus 2 corresponds with 5. Now let me point something out. I've not said a lot about this, but make sure when you're setting up these proportions, if you say 3y minus 2 goes with 5, I said something from the bigger triangle goes with something from the smaller triangle. Bigger triangles on top, smaller triangles on bottom. Make sure as you come over and do the other side that you also put the bigger triangle measurement on top, the smaller triangle measurement on bottom. If you want to do 5 over 3y minus 2, that's fine. If you do 5 over 3y minus 2, you'll do 2 over 4. Solve it to get rid of 2. Multiply by 2 gives you 6y minus 4. To get rid of 5, multiply by 5 gives you 20. You get the exact same answer. This is neat. Perimeters of similar polygons. If two polygons are similar, similar polygons, then that implies that their perimeters are also proportional. And the same scale factor is going to exist between the perimeters. Proved. Let me draw 2 triangles as you're writing that down. You got a triangle. You snap it together, duplicate it. You have a second triangle. Now those 2 triangles again, those would be congruent. I'm going to shrink it down. And let's say that we have side lengths of 3. Just to make it simple, let's do side lengths of 3, 6, and 9, and side lengths of 1, 2, and 3. Those 2 triangles are proportional. Those 2 triangles are similar. How do I know they are? Because, well, number 1, I just shrunk it down. And number 2, if I look at the sides 1, 2, and 3, I notice there is a scale factor that exists between the small and large triangle. The large triangle, all 3 sides are 3 times bigger. The small triangle, all 3 sides are 1/3 as big, or divided by 3. Now, what we're doing here, again, we see the scale factor. Scale factor is times 3. Or if you're going the other way, times 1/3. Now, the question is, what is the relationship between the perimeters? Perimeter is the distance around. Help me out. Sydney, what's the perimeter of my small triangle? Add up all the sides you get. 6. The perimeter of my large triangle, 3, 6, and 9, gives me 18. Look at your scale factor. And what this theorem states is, if your scale factor from one shape to another shape is 3, 4, 5, whatever it is, the scale factor between the perimeters will be the exact same scale factor. Okay? With that said, let's work a problem. Says these 2 shapes are similar. So that means that their side lengths have a scale factor. Some scale factor exists. Let's see if we can find out what that scale factor is. RS is the same thing. This is 3 also. Tick marks, that'll be 4. This will be 8. And we see from our similarity statement that AE is similar to PT. AE, and that's weird, it kind of flips over to the other side. AE is similar to PT. Let's go in the direction I drew the arrow. I want to know, how can I go from 4 to 3? What can I multiply 4 by that gives me 3? That's what I'm looking for. That is your scale factor. That's how you find your scale factor. Is how can I go from point A to point B? What can I multiply by? And that would be your x. If you solve this by dividing, pretty simple. Your scale factor is 3/4. So your large shape times 3/4 gives you your small shape. Your small shape is 3/4 the size of your large shape, side length. And what it asks us to do is find the perimeter of the small shape. So there's an easy way of working this, and there's a hard way. You've got side lengths of 8, 8, 4, 4, and 6. And if you want to, you can multiply all those by 3/4 and get these side lengths. You don't have to do that. Look, the perimeter here, 14 and 16. The perimeter here is 30. Double check me on that. 16, 24, 30. Right. If the perimeter of your first shape is 30, then all you have to do to find the perimeter of your second shape is multiply by that scale factor. You do 30 times 3/4, or 3/4 of 30, and that's going to give you your new perimeter. That's 90/4, 45 halves, or if you want to divide it, that's going to be 22 and a half. You didn't have to go through that math. All you had to do, take out your calculator, multiply. 30 times. Now on these calculators, you can do 30 times 3/4, 3 divided by 4. 22.5, same answer. On your calculator, you might have to do 3/4, change that to a decimal, that's 0.75, and then do times 30. Either way, you get 22.5. So again, in a nutshell, if two shapes are similar, there's a scale factor exists. The scale factor between the sides will be the same scale factor between the perimeters. Last one of those. If these two shapes are similar, then find the missing perimeter. Let's see, Cole. MQ, or W, we've only got one side length here, WX. Look at your similarity statement, Cole. What does WX correspond with over here? Good. Find WX. What? W then X. MQ, there we go. Or QM, either way. So 4 corresponds, thank goodness, with 8. We like that. Scale factor, 4 times 2 is 8. We don't have to do anything hard about it. The second shape is twice as big as the first shape. That means its perimeter is twice as big as the first shape. The perimeter of the second shape, we can find it at 15 minus 24, 34. That's the perimeter. So can somebody tell me what the perimeter of the first shape would be? 17. That's all you have to do. Okay. Any questions? Now later on, a few chapters from now, we'll talk about area. And I will go ahead and tell you, the area does not have the same scale factor as the side lengths. It's a little bit different. Okay. Last sections, we talked about how to prove that two triangles are congruent. We have 5 methods for proving triangles congruent. Triangle congruency. They were side, side, side. If all 3 sides of one is equal to all 3 sides of the other, they're congruent. Side, angle, side. Angle, side, angle. Angle, angle, side. And if it's a right triangle, hypotenuse. We need to know those. Okay, those are standardized tests. You see that a lot. Well, we're not talking about congruence anymore. We're now talking about triangle similarity. And we also have methods for proving that two triangles are similar. Are these going to get mixed up with the other one? Probably. Yeah. In our head, we're going to flip-flop back and forth. We're going to mix them up. But luckily, there are only 3. Now, the past few problems, we know methods to prove that two triangles are similar. Well, if all the angles are the same and all the sides are in proportion, then that's what we've done on the past few problems. You don't have to do all that work. You don't have to prove that all the angles are the same. You don't have to prove that all the sides are in proportion. Not all the sides are congruent. but all the sides are proportional. This gives you one method. I'm going to go ahead and give you all three of the methods. Okay? One method for proving that two triangles are similar is called angle, angle. Some books call it angle, angle, angle. But think about it, guys. Third angle theorem, if you know that two of the angles are congruent to two of the angles over here, don't you already know that the third angle is also congruent? So really, you don't have to prove that all three are. You just have to prove that two are. If you know that two angles of one triangle is congruent to two angles of another triangle, those triangles will always be similar. And once we know they're similar, not only do we know the angles are the same, but we know the side lengths are in ratio. They have the same scale factor. The next method is side, side, side. And that seems somewhat confusing. Because I thought we just used side, side, side to prove that two triangles were congruent. Yes. This is a different type of side, side, side. This side, side, side stated, if all three sides of one triangle are congruent to all three sides of another triangle, then they are congruent. This side, side, side states that if all three sides of one triangle are proportional to all three sides of another triangle. And I'll show you in a second how you can check that. And the last one is also off your other list, side angle side. And this one states, and keep in mind what you need to know about angles and sides. This one states if you have one angle and it's congruent, that's very important. It's got to be congruent. If you can prove that one angle is congruent to another angle in the other triangle, and the two side lengths are what? Not congruent. Proportional. Because, guys, again, if the angles were congruent and the sides were congruent, that's what this one says. Those two triangles would be congruent, not similar. If you have an angle that's congruent and two side lengths that are proportional, now how do you check proportionality? You either use proportion or use a scale factor. That's what we've been doing. So here we go. Work a couple of problems just to show you what we mean. Are these two triangles similar? First off, I know they're not congruent. Look at them. That one's bigger than that one. I know we can't judge by just looking, but it doesn't look like it. Now, are these two triangles similar? There are three methods for checking for similarity. Angle, angle, side, 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 angle, side. You know absolutely nothing about the sides. The only method you could use here is angle, angle. No, the angles are the same, so we're done, right? No. Check that third angle. 48, 57. Somebody do the math there for me. I think that's 105. What would be the third angle? Thank you. Are those two triangles similar? This angle is the same as this angle. This angle is the same as this angle. By angle, angle similarity, these two triangles are similar. And I believe you're also supposed to write a similarity statement. Triangle JKL is similar to J corresponds with Q. K corresponds with P. L corresponds with M. Since they are similar, you can set up a similarity statement. I want to know, are these two triangles similar? That's a pretty cool problem. You got all you're given is that you have parallel lines. And you have this hourglass looking shape. Well, don't I know that these are congruent? Vertical. Don't I also know that R and W are congruent? What are those called? What type of angles? You see the Z. These are vertical. These two are alternate interior angles. Good. Since you've got parallel lines cut by transversal, these angles form alternate interior angles. And if you wanted to, you could go a step further and say these would also be congruent. Are these two triangles similar? Yes, by angle, angle similarity. Your similarity statement would be SRX is one way of writing it, is similar to. S corresponds with S. R corresponds with W, and X corresponds with T. I want to do one with sides. Those are not similar. Those would be similar. Let's do this one. Trying to prove that these two triangles are similar, then we're finished. You have two methods. You could use either one here. I can either use side similarity, or I can use side angle side. Because does anybody see two angles that are equal to each other? You see the verticals, right? So what you can do is you can either test, now again, be cautious. You're testing to see if two sides are proportional, not congruent. So here's how you test that. We'll do it with side. But I'm just saying you could use side angle side. How do we know what corresponds? That's the hard part, right? What does, let's not think about what I said the other day. What does 5 correspond with? Be careful. 5's the small side, right? What does 5 have to correspond with? What does 6 have to correspond with? 12.5. And what does 8 have to correspond with? 20. In order to be similar, we don't have to know anything about angles. We are going to use side similarity. What that states is if 3 sides of one triangle is proportional to 3 sides of another triangle, they are similar. One way of checking that. 5 goes with 15. 6 goes with 12.5. 8 goes with 20. In order to be similar, those 3 must be proportional. They're not, by the way. These two triangles are not similar. What's the easy way of doing this? 5 and 15, what's your scale factor? 3. In order to be similar, that same scale factor must exist all the way around. This couldn't be 20, it would have to be 24. This couldn't be 12, it would have to be 18. These two triangles are not similar because the scale factor does not exist for all 3 sides. Here we go. Let's try this problem again. My bad. 5, let's try it again. Since 5 is the smallest, 5 corresponds with 12.5. And I apologize if somebody said that. 6 would have to correspond with 15 since those are the middle sides. And 8 corresponds with 20. 5 and 12.5. 6 with 15. And 8 with 20. Now the way I worked it, again, I just want to give you an example of what not similar would look like. Let's see, are these things truly similar? One way of doing it, divide 5 by 12.5, 6 divided by 15, 8 divided by 20, and see, are all 3 of those numbers the exact same? Or, you could say, you could try to find the scale factor. 5 to 12.5. 5 times something gives me 12.5. I like this method better, honestly. Divide by 5, you get a scale factor of 2.5. So you could test and see, is that scale factor hold true for all 3 sides? If you multiply 5 times 2.5, obviously you get 12.5. That's what I solved here. Check the other 2. Multiply 8 by 2.5. What do you get? Do you get 20? You do, don't you? Multiply 6 by 2.5. What do you get? 15. So the reason I like this method better is because not only have I proven by side, these two triangles are now indeed similar. You got to pair them up right. But I've also told you how much bigger the second one is than the first one. Not only are they similar, but this second triangle is 2.5 times bigger than the first triangle. Which, by the way, if y'all know how to change it to a fraction, 5 halves is the scale factor from small to big. 2/5 would be the scale factor from big to small. So they are similar, and you actually have the scale factor now as well, which is 2/5.